Welcome, everyone, to a behind-the-scenes look at what Tableau actually does when you set up cross-database joins and unions. My name is Alan Folting. I'm in the product management part of our development team, working in the database group. I've been with Tableau for a little over 3 years now, and have worked on various query-related projects, many of them with Pavel here.
Yeah, so I'm Pavel, also a manager on the data group, and I've been with Tableau for almost 7 years, working on query processing, on performance. Maybe some of you remember our talk from last year about dashboard performance. Also on the data engine that we'll be talking about here. And currently we're working on Hyper. I'm in Munich for a little bit.
Cool. But just to make you know a little bit more about us, other than just what we said now, we thought it'd be fun to mention a couple of fun facts. So I don't know if you've met Pavel before, but if you haven't, you probably wouldn't guess that he's actually an excellent dancer. Not only does he participate in various dance congresses and competitions, he also takes any opportunity he can at any Tableau party. So see if you can meet up with him during this conference, and you'll see his excellent skills in action. From the picture up here in the top left-hand corner, you probably would think that Pavel likes beer. He actually does not. But as he just mentioned, he's in Munich for a year, working on the Hyper team with the folks there. And what do you do when you're in Munich during Oktoberfest?
Yeah, well, actually the Oktoberfest is in September mostly, but this I found out in Germany. Well, that's true. We often work with each other, with Alan in Kirkland or in Seattle, and I run to my dance workshops, but he runs to his hockey trainings. Here you can see him celebrating after winning some hockey tournament in Pacific Northwest. So they're pretty good. More than hockey, he likes speed. Here he kidnapped some random Ferrari, I think. He rides everything. Motorcycles, he goes to racing tracks. It will be pretty hard to chase him down here at the conference. He's a pretty busy man.
Yeah, unfortunately, that's not my car, but it was a fun day there. So what we're going to do today is we're going to have some slides, then do a demo to show some of the concepts in action, and then repeat that 2 to 3 times, depending on how far we get, hopefully all the way. Pavel will do the in-depth talk for how we've implemented this feature behind the scenes and what strategies we took and what you have control over in terms of how you build your workbooks and what will then happen under the covers. And so we'll do that. And I would say for questions, if you have a burning questions along the way, raise your hand. We probably won't take a lot of questions just because we might not get to the end then, but we'll take a few if it's a burning question, so feel free to raise your hand. And we may stop the questioning if it gets out of hand.
Yeah, and there will be lots of time after the session. We can just meet outside and play even with your workbooks.
Yeah, and at the end, we'll talk just a little bit about what's coming next to further enhance functionality in relation to these features we're talking about today.
So if you think about it, adding data integration to Tableau is a pretty natural choice. Even in Tableau 6, we already had data blending, and that's when you're in the middle of the analysis and you feel that, or you want to paint something with secondary data, with columns from other data sources. It was useful, but had this one big disadvantage that it wasn't part of the data model. You couldn't publish the data source with secondary dependencies. You couldn't share formulas that reference some secondary columns. You couldn't extract that data. So that's from the point of view of the need. But also, there was a lot of pre-existing capabilities in Tableau that helped us to develop the data integration feature. So of course, if you want to federate the data, integrate the data, you first have to access it. And for that, we have an excellent layer, connectivity layer, that has been with us from the very beginning, because at the very beginning, we were just connecting live to data sources, right? So we can generate complicated SQL against many data sources. We support over 50 different connectors. We also shield Tableau from third-party code. We know how to work with third-party drivers. Some of them are asking for too many resources. Some of them are crashing. We need to know how to handle that. Many of them are under-documented, so there's a lot of digging and understanding their dialects of SQL. And then once you access the data, you have the choice of either processing it remotely, sending this dynamic SQL, or processing on our end. So for that, we have our Tableau data engine. On top of that, we have an optimizer. We perform a lot of simplifications before we send queries. So we do constant folding, join calling, just because there's a lot of missing functionality in the optimizers in the backend. Does it mean that we want to replace ETL tools with data integration in Tableau? No, of course we want to introduce more features in Tableau. But there are two reasons why we still want to have ETL tools, especially Maestro. One of that is just the loss of physics. There's a lot of scenarios where you have large volumes of data, and Tableau is a very interactive product. So you really don't want to spend too much time on the preparation when you're about to do data visualization. The other thing is that you want to keep the trade-off between the capabilities of the application and the simplicity. And Tableau is pretty easy to use, it's very accessible, while some of the ETL pipelines are actually really hard to grasp at the very beginning. So when you deal with models that are pretty easy to, well, it's pretty easy to tell that they will be useful across the whole organization. Let's say you have Salesforce data and your internal employee data. You can build them once and publish in the tool like Maestro. But if you actually want to just explore the data and you're not going for very sophisticated functionality in data integration, then you use Tableau. So we'll talk about two features, cross-database joins that were introduced in 10.0, and about union that was introduced in 10.3 and then further improved. So we kept exactly the same API for creating joins as we had before. Just now you can have multiple connections and you can add tables from different connections within one data source. And that is a federated data source. We still have two scenarios, live and extract. For a single connection data source, live meant that we are sending SQL queries, getting data on our side, and then post-processing. And it's similar for the federated scenario. But now let's say you have two connections, SQL Server and Oracle. And we will be sending parts of the queries, just sub-queries, to Oracle and SQL Server, bringing the data for federation on our end, post-processing, and then generating visualizations. So live means that we will do that. We'll do all this data movement on every single query, and a dashboard can have tens of queries. The second scenario is extract. This is where we have much larger volumes of data, because you see there will be a lot of data movement. So if this is not just a few databases with less than 1 million rows or text Excel files, you might want to use this scenario. So in this case, we do a single federated query at the very beginning. It's basically a select star over your federated model. And after this query is done, after we get these intermediate results from remote data sources, again, let's say SQL Server, Oracle, we post-process it on our end, and then we persist the result as an extract database. All the subsequent queries will be going against this extract, so they will be TQL queries if you look into the logs. And that's why they will be much faster. You don't have to move the data anymore. Everything is local. Union, that handles the scenario where you are thinking about a single logical table that is physically partitioned into multiple pieces, let's say multiple files. Today, we support Union for text and Excel files in Tableau. And in the interface, you can either manually choose files, just cherry pick them, or you can use a wildcard filter. And that comes really handy when, let's say, you have agents working in the field, sending you information about customers that they just visited. Or you get transactions from some remote departments every single day, and you end up with a folder or multiple folders of either text or Excel files. So then you can have a wildcard filter over the names of the files, Or in case of Excel, you can have two wildcard filters across the files, and then within each workbook across the sheets, because sometimes we like to put the data on multiple sheets. And in this scenario, we expect that all those files, all those tables, have exactly the same schema. If they don't, for some reason, somebody added a column, removed a column, we will just fill it with nulls. So it will be still useful for analysis. And in most cases, the intersection is what you're really looking for. What's the experience like? Well, for text and Excel, live means that we'll always parse the files at the very beginning, even in the data prep pane, and we'll create a shadow extract for them. So every single file or every single table in Excel will become a table in the data engine, and that happens behind the scenes. For Union, you might easily have 100,000 files, so we would have to create 100,000 tables. We don't do that. We immediately materialize them into a single Union table. So all the queries, subsequent queries, will be again SQL queries against this shadow extract, so against the data engine, and against this one table. So now let's see those features in Tableau.
Yes, I will switch over. Okay, so as a refresher, I'll first start by introducing the UI for doing cross-database joins very quickly, and then we'll dive into some more details. So as you probably know, actually maybe I should ask, how many here have not tried this in Tableau to select tables from different databases and joining them together? There's some, okay. So it might be actually helpful to do a very quick refresher here then. So it used to be before 10.0 in Tableau that when you create a data source, there would be a one-to-one relationship between it and a connection to that data source. So in 10.0, when we introduced cross-database joins, what you see here now, and I can highlight this top section here, up here is, that's my data source, and you can't see the full name here, but it's not important, but it says weather plus, and that data source is still a data source, but on the left-hand side here, you'll see that it has more than one connection. In this case, for this demo, I have an instance of Hyper running on this machine, a MySQL Server database instance, a Postgres database instance, a SQL Server database instance, and then I have some text-based CSV files that I need to use for my analysis. The data set that I'm using here is, if you went to the keynote and saw the Hyper demo there, it's a smaller version of that same demo set with the weather observations. It's not 3 billion on this machine, but it's still the same data set, just a subset. So what I've already, just to save some time, added these 5 connections on the left-hand side for this data source. And what I'll do now is I'll start using more of them. So far, I've only added 3 tables, and those all come from the same database data, or connection, sorry, in this case. So there's nothing new in what I've done so far. We're not doing a cross-database join yet. But if I go to MySQL, and I drag in a table from there, it'll be added. You'll see some things happening on the right-hand side, and I'll get to that in a minute. And I can add a table from Postgres as well, SQL Server. Let me see which one I want down here. I think I want this one. And see, in this case, just to show you as an example, this is probably going to be hard to read, but I'll try. Sorry, wrong button. So there's a type mismatch in this case. See, one of the columns on one side is a string, and the other side is a number. So if you've used this before, you've probably run into this, and you can fix this in various ways depending on the data source, custom SQL if it's a database, or you can change the data type in Tableau if it's a text file. So that was just to show you that example. So I'll take this out again, because this I don't need to change. And I will add, I actually skipped here to the text files. And so far I've added data from 3 different data sources, and I'm going to now add some weather station data from text files. And so when I drag in here, in this case, I have to specify the joins because there's not the columns on each side does not have the same name. So I'll quickly do that. I happen to know that this is the one to use. NCI and weather station identifier. So just a sec here. There we go. And I'll select the same on the other side. And so now I've added one text file. As we just talked about, you can union files here. And so what I'm going to do now is I'm going to add a second set of weather stations, because I happen to have various different weather stations in different files here. So if I can drag that on there. Oh, sorry, I did that wrong. I replaced it. I need a little more space, and I need to go to the right thing. Oh, yeah. I am sorry. I'll take this out. I got the wrong. So do you have something clever to say, Pablo, while I fix this?
No.
My mistake here was that I added the text file not as a union. I happened to drop it next to, so it became a separate text file, and I needed to hit the union space. So I'll do that now, hopefully get it right like this. Because then it already knows that the join is defined that I did before. Sorry about that. And I'll just go ahead and add the rest also. So I have all my weather stations. So a quick little refresher on union, as well as just cross-database join in general. So now what I have is a workbook that uses, in this case, one data source with the 5 connections that I have, and I'm ready to go do analysis. And from now on, everything will work as if these tables came from one data source. Makes it a lot easier as a user to understand what's going on. I will jump over to a text editor here and just show you, I'll zoom in a little bit here too, show you what this looks like from the Tableau file perspective and the XML definition in the TWIB. And what you'll see here, you'll see that same connection defined here in the XML at the top. And underneath, you'll see all the individual connections for that data source. Sorry, I meant to say data source. You'll see Hyper at the top, then MySQL, Postgres, SQL Server, and then the CSV file with a path to where the files reside. So this was just a quick little brief demonstration of setting it up. And we've got a file that now does cross-database joins and unions. And we'll come back to looking at the flow of what actually happens behind the scenes in the next demo.
Right, and here we saw how to define union just manually, just by dragging and dropping the files we want. We can later modify it. We can click and open the dialog that we showed in the slides, and let's say add a wildcard filter. Modify if we want to go to all the subdirectories or the current app directory. Okay, so what Alan just did, he went through the first stage of what we call data modeling in Tableau. So this is where you are in the data prep pane, and you generate your TDS file. So this is how you internally represent the data model. So that's where we have pivots against X and Excel. That's where we have custom SQL tables, stored procedures. We also define data source filters, so global filtering. And then when we move to the data pane in the visualization canvas, then we can do more in terms of data science. So we can add categorical beans, numeric beans. We can add LOD calculations. We just announced the Python server, so you can have scripts in Python. So pretty much can do whatever you want. Our scripts very soon will be integrating also with Mathematica. And all of that together is a single entity for Tableau. You can publish it to the data server, you can extract it, you can share it for collaboration. On top of the data model, we build visualizations. And here we have an example of our favorite data set of flights, a dashboard with multiple zones. Each of the zones is defined by a so-called visual specification. So that's basically what you drag and drop on the shelves, and all the formatting options and all additional analytic tools you defined. When you do a single interaction with this dashboard, we will take all the visual specifications, analyze them, and figure out the queries that are necessary to retrieve the data for the next step. We'll batch them together. And batching means that within a single batch, all the queries are independent. You can run them in parallel. And in many cases, there's only a single batch. You can then perform simplification just within this one batch, and you can realize that, some of the queries can be fused because they're bringing different measures over exactly the same view of data. Or some of them are redundant because I'm bringing the whole domain, and with different query, I'm bringing a filtered domain. So maybe I can just do the filtering locally. I don't have to send a second query. So we do that as the second step. Later on, we send batches for execution. This is where we talk to the intelligent query cache. This is where we check that, or maybe some other user already executed this query. It is different from batch reduction because when we're reducing the batch, those queries are not cached yet. We never sent them. Then we run queries in parallel. We have a connection pool. We don't want to open connections every single time, especially that we're sending so many queries. And we can share those connections across users on the server. Then we consume the results. We do post-processing. This is where we apply those Tableau-specific operations like geocoding, densification, linear regression, clustering, the new ones, table calcs, and then we render. The federation piece happens when we run queries. The only difference from what it used to be is that now the queries are over those federated models. So exactly what Alan showed you, just the data model is different. Of course, we had to learn how to process the data, and here's our strategy. Data federation, in principle, is about two things. It's about how to allocate pieces of the query across the connections, so where you perform the computation, and the second thing is how you move the data around. And you can come up with a lot of different strategies. Let's say that, again, you have SQL Server and Oracle. You can move all the data from Oracle to SQL Server, send a single query against SQL Server, and then consume the results. And of course, depending on the volumes of data, of the capabilities of the data sources, different strategies might be good. And that's for every single query. The strategy that we chose is a systematic approach. We always do it the same way. Because of that, it's predictable, easier to grasp for the users, but also predictable in terms of performance. We try to minimize the data movement. We send queries to the remote data sources, and we try to send the operations that will reduce the size of the data we retrieve. And then all those pieces of data are sent as temporary tables to the data engine. The data engine is our federator node. And some advantages of that. Well, we know capabilities of the data engine and semantics of the data engine. We can control them. We can always add something. Of course, there are challenges because some of the capabilities of other connections that are in the data source need to be adjusted. And we'll talk about it more. Also, from the security perspective, it is easy to tell what's happening. We already agreed to send data, secure data, to Tableau to visualize it. But we might not be cool with sending, let's say, a confidential Excel workbook to some SQL Server database that is shared across the organization. So that thing would have to be immediately communicated to the user. So now let's see how the strategy is implemented with the queries in the product.
Yes, so we're back here where we left off last time. And what I'm going to do now is I'm just going to create a simple visualization to get some queries going, and then we'll look at the flow and the order of operations from the log view on the right. And I apologize for the denseness of it. There's a lot of events. I'll try and zoom in and expand the ones that are relevant, and raise your hand if something is unclear. So let's go to a sheet and make this a little bigger while we do that. In this case, I'm just going to do a simple map that shows all the weather stations around the world. And this is actually filtered a little bit, and as I mentioned, it's not the full data set. So, but there's still quite a few weather stations listed here. I can go and say, let's put number of observations on size, for example. Maybe adjust the size a little bit so we can better tell the difference, maybe. And we can zoom in a little bit, maybe, to make it more visible. But basically what you're seeing here is the size of the circle. It's the number of observations coming in from that particular weather station. And you see there are quite a few of them around the US and around the world in general. So that gives us enough to kind of go back and look what's going on Because remember, the different pieces of data we're using here are coming from 5 different data sources. So while that happened, let me do a refresh here, so clear this, and just refresh this sheet. So do it all again. So this is the actual flow, and again, I will zoom in, and I know it's hard to make sense of at this high level, at this low level, I should say. So, but very quick overview of the flow, and then I'll dive into some specific events. So, because I did a refresh, first we do all the metadata gathering from the different data sources and all that, and that's off the screen right now. And then we get to the federated query events. Below there, you'll see the actual flow of what I'm going to walk you through. So, as Pavel mentioned, we will query each of the data sources for the data we need from there. And then at the same time, while we're doing that, at the beginning of doing that, we'll create a temporary table in the data engine. And as the data comes back, we'll populate it into that temporary table. We'll do that for each one. And you'll see the flow for every of the blue lines kind of signifies one of these events for each of the data sources. And so if I go in and look here at, say, let's pick this one here, then I'll zoom in a second. Here you'll see a simple query to, I can't remember if it's from MySQL or Postgres in this case, but it's going to one of those external databases, and since I have no filters or anything going on, it's literally just select all the information from that particular small table. And then after that step, you will see down here that we create a temporary table in the TDE to hold that information. Not a super interesting statement here, but still. Create table. And then we're going to go ahead and add each column, which is the next event you see below here. Create this column here in that temp table that we just created, and the second column is the next statement. So that happens for each one. So once that's done, these sections with the blue lines, for each one, we will have one temporary table for each of the data sources. And then the actual federated query to populate the map that I showed can happen. And so that then becomes, zoom in a little bit here, that then becomes a data engine, Tableau data engine set of joins between the tables that I had, that you saw that I added earlier on. And so that's simply what we're doing here, sending a SQL query against the data engine that references those temporary tables that we just created, and therefore it becomes a local join in the data engine. In this flow, in real scenarios, most of the time is spent on retrieving the data from the external data source. Depending on what data source it is, how much data, network, et cetera, it can take that longer or even a lot longer than what it would have been had it been local. So that's pretty natural. But as you'll see, if you actually go home and investigate some of these events, you'll typically see that the actual query at the end, in most scenarios, is super, super fast, whereas it takes a little while to set this whole thing up, retrieve the data, create the temp tables.
Two important points here. Today we retrieve the data serially. So if you look at the log, if you try to draw a Gantt chart, even if you look at the performance recording, you will see that we are running a query here against Hyper, then we are running a query against Postgres, against the TDE, and then finally the final query against the TDE to post-process the data. That's one of the things that we are improving in the next version. You will also see that the query against Hyper, because we had three tables joined together, there's a single clump in the UI. Okay. This join will happen remotely. You will also see that a lot of filtering happens before we bring the data on our end. And another very important thing for the live scenario, we are bringing only the columns that are referenced in the V's. That's why the live scenario makes sense. Otherwise, it's basically bringing all the data like to create an extract, but we would do it on every single query. So you will see that if you just want to get a feel on the data set and see the number of records, yes, we are querying all the data sources. And yes, we are performing the joins, so we have to bring the keys. but we're not gonna bring, let's say, 50 columns that are in every single data set. And from our experience, there's a lot of white tables in your data sets. So that was to grasp the idea.
Yeah, I included in the deck for your reference, if you downloaded, some of these events that I used to highlight, so the colors. So what I did in the log viewer is I said, only show rows that contain these words. It's that simple. So just in case you were to download this and want to try it at home, you can. And especially now that, if you continue, especially now that we've made the Tableau log viewer that I showed here available for everyone, it becomes a lot easier to do this at home. I hope that if you're interested in figuring out how things work or just have things or Tableau workflows you would like to debug a little deeper, that you'll download this tool and use it. And it's open source. You can even contribute to it. You can download the source code, build it, or you can download binaries from Mac or Windows and install it and use it. And I can't say how helpful it's been for us internally to use this for various situations. In this context of this, figuring out, are we actually doing the right things? Are we pushing down the filters we expect to? Are we, or not when we shouldn't, and et cetera. So I can't highlight enough how valuable it's been for us. I hope you'll find it useful too. But there's a link there to download it.
Yep. Yes.
Does the log shark support these kind of queries when you try to parse your list logs?
I didn't get the middle part. Can you repeat?
Does the log shark support these parsing exactly these queries when you are talking about performance to see the query from what workgroup exactly the database and see what's happening and so on and so on?
I am not deeply familiar with the LogShark, but
Yeah.
so do you have a,
I'm not.
sorry, the question was whether LogShark, if you know about that tool, can parse these types of logs and look for performance issues. And
So we would guess yes, because this is a JSON format, and we actually changed our old legacy logs to this format for analysis with Splunk, with Sumo Logic, with a lot of other tools. So I suspect yes, but again, for the query, you will see just a blob of text, and you can try to, like, for example, we also have a visualizer for queries. That is maybe not that interesting here. But yeah, you should be able to browse those events rather than using some other viewer editor for JSON. Yeah, this tool is currently running on my machine and on most of developers' machines at Tableau, so you're pretty much getting your hands on a piece of software that we are using to develop Tableau. So the idea is that we are moving the data to the data engine and then post-processing. A few details and challenges that we had with federated data sources. So Tableau defines its own type system, and over that type system, you have a library of functions. So same like in Excel, you have formulas and you can use Excel functions. Same in our calculation dialog, we use our Tableau functions. And then if we work with different connectors, we are trying to map the types and the functions to the remote types and remote functions. And usually the remote type systems are richer. And we do operations like here. Let's say we don't have time as a type in Tableau, so we would map it to date time. We try to keep our type system pretty simple, but still powerful. Also, we don't really work on large objects, because this is not something that you want to bring for numeric analysis. But we still do support them, and we truncate them, for example, to 1,000 characters. And now imagine that you have a function like contains. It's a Tableau function. And you want to implement it somehow in the remote database. First of all, we keep the semantics of the type system. So regardless whether we bring the data on our end and we run contains, or we actually send contains to the remote data source, we'll put this cast there. So you will see it in the queries. And that's very important in federation because we do a lot of data movement. We need to make sure that the semantics stays the same, regardless of the optimizations. The second very important choice was, what do you show in the calculation dialog? If you have a single data source, and we know that, let's say, 90% of the Tableau functions are implemented by, say, SQL Server or by Oracle, we just show those. But now you have multiple connections in one federated data source. So we had two extremes to choose from. One, let's take a union of all the supported functions. So if there is, let's say, split or any function that is supported in any of the connections in the federated data source, then we could say yes. Yeah, we show it and it's available. But that means that our solution, again, wouldn't be that systematic anymore in terms of performance, because let's say that most of the data lives in a connection that doesn't have this function. We would have to move all the data to the one that supports it. So we chose the other option, the option where we actually take the intersection. So a function is available only if it's available in every single connection in your federated model, including the data engine, because the data engine is implicitly part of any federated model. And it's actually not a serious restriction, because Tableau today implements most of the functions anyway. When we did a review of all the connectors, we realized that only functions that are not row-level calculations are missing. So median, split, sometimes CanDistinct would be missing. But in most cases, you can just express Tableau functions through less or more complicated expressions against formulas against remote databases. We did exactly the same thing for join types. So let's say that you have a connection that doesn't have a full outer join. That happens. Or right join. Then you cannot use them in your federated model. Otherwise, left joins and inner joins are pretty much available everywhere. In the first demo, Alan showed you a situation with a type mismatch. So let's say you have two tables and you have date and date time, but they actually mean exactly the same thing, right? We allow users to explicitly fix this join, simply because types are exposed in Tableau as a first-class citizen. We do differently for collation mismatches, because collation is harder to grasp by the users. It's really about how we compare values in the domain. So let's say you want to sort a column, or you want to simply do a join and say, is Abba equal to Abba, but you use a different case, right? That's defined by the collation. It's also very important for range filters. A lot of issues that we see on, I would say, exotic languages, where you get completely different results, is because there are differences between the collation library we are using, and we are using ICU, which will be very soon taken over by the Unicode consortium, and the collations that are used by the remote databases, let's say by SQL Server. Sometimes this mapping is perfect. Sometimes there are some differences, and you can see that in one tool, when you go against the same, or you just run a query against SQL Server, you get a bit different order than in Tableau. So those mismatches we fix automatically for users. And that happens a lot. Let's say you have a text file. You don't really have any collation. You have just binary collation. And you have an Oracle table, and the key has some, let's say, Latin 1 collation. In this case, we'll choose the binary collation for the user, and immediately we'll get some results. With case sensitivity, if you have exactly the same collations, but there's just difference between case sensitive and insensitive, we'll choose the stronger one, the case sensitive. The last thing that is worth pointing out is that we have kind of two types of joins in our federated model. The ones like in the demo for Hyper, where we had joins that will be executed remotely, and the joins that are federated. They will be always executed on our end in the data engine. We use ANSI null semantics for all the joins. That's the preference of most databases. That means that nulls are not equal to nulls. We treat them as unknown values. And it's not always like that. It's not always the best choice. There is a case, very popular case in Excel and also in Tableau, where you want to treat them as missing values. And that's where you have a quick filter and you have a null value, and you expect that choosing this null value will show you all the rows that have this value missing, that's value equal to null. So then you say null is equal to null. We implement both, either directly through some built-in operations, it depends if the database supports them, or we just generate longer expressions. That's a bit slower, but it's still correct across all the connectors. So now you remember the the general strategy that we are running queries against the secondary data sources, move the data, and eventually post-processing the TDE. This is how it looks in more detail. We start with a query, and query is just a bunch of filters to us, level of detail, some calculations that we have to apply, and the output columns. And then we resolve it using the metadata we retrieve from remote data sources to a tree, just because it's simpler to work with a tree. And this is when we apply optimizations. We simplify predicates. Some of the predicates, especially multidimensional sets or large filters, will be expressed as a large table. This is where it happens. We fold constants. After the logical tree is simplified, we try to partition it into groups of operations. And we associate those groups of operations with different nodes. So in particular, we say, OK, we're scanning a table of sales with some filtering on SQL Server. And then we're doing something against Oracle, let's say, grabbing customers. And then we're bringing that data further for analysis to the data engine. So one optimization that we are applying in 10.0 is predicate pushdown. So we will try to push filters as low as you can. And because of that, we will be decreasing the size of the intermediate results we're bringing. So this is where data source filters come handy. That's also true for a single connection data source, but here it's even more important. After that, we try to build those clamps as big as we can to push down as much computation as we can closer to the data, and then post-processing the data engine. And the processing happens in a cycle. We take the piece of logical tree, we generate a piece of SQL, run it, create temporary table in the data engine, and so on, and move to the next data source. Eventually, we run the final query against those temporary tables. Caching. Caching didn't really change much from what was happening with a single connection data source. We have a metadata and capability cache that tells us about the connection, the characteristics of the connections. I mentioned that we open a lot of physical connections to different databases. And that, let's say that user one connecting to some federated data source will ask for table customers from Oracle. We'll cache all the information about columns of this table, including all the remote properties, like is it nullable, is it unique, are there any primary foreign key constraints? We'll also cache capabilities of databases. Let's say what's the driver version, and so we can adjust the dialect. What is the support for temporary tables, indexing of temporary tables. So then user B that is connecting somewhere else in the cluster, because this cache is distributed on Tableau server or Tableau online, will actually take advantage of this information. They don't have to send those queries again. Then after we prepared the batch of queries and simplified it, we are trying to run queries. And this is where we talk to the intelligent query cache, also distributed, also available across the whole cluster. And this is where, before you get to query execution or any data movement, you can realize that, well, I have a vs where I have sector, region, and some filter. And if I drop sector from the shelf, well, I already have the data in my cache. I'm actually asking for fewer data, so I can just roll up in memory, and I never send remote queries. Same with filtering. We already had a few checkboxes checked, and now we're just removing some of the checkboxes, but we have more data in the cache. So this is available, again, across nodes on SQL Server, on Tableau server. And now let's say we failed, and we actually have a cache miss, and we have to do the federation. Still, if we send those queries against SQL Server and Oracle, we'll consult an in-memory cache that we have on every single node and check if that query was already executed. This cache is not distributed across the clusters because we would duplicate a lot of data. Imagine that you have a miss in the cache, and then you populate the intelligent query cache and the literal query cache, and you have the data represented twice. Within the node, it's easier to optimize it. Connection management, again, is very similar. We do not have any capabilities or configuration at the level of the federated connection. You remember Alan showed you this representation, internal representation, that we have a federated connection, and then we have the member connections. But you still configure member connections in exactly the same way as before federation. So if you have SQL Server and by default, let's say you have 16 connections, you can say, well, I want to have 100 on my SQL Server instance. And that goes across all the federated models. You don't specify that I want those physical connections just for this model, because that wouldn't really make sense. You just want to decide on your resources, and you want to share those connections across all federated models in your system. The same pertains to the data server. Also, if you have a generic ODBC connector or any connector, you can use TDC files and you can change capabilities. You can change capabilities directly in the TWIB. If you want to have everything in one workbook, you can just edit that and add capabilities there. So here nothing new. I mentioned that the TDE connection is part of of every single federated model. So here we don't have any limits on the number of connections that are used for this post-processing. We are using a temporary database that will live until we kill the process. And the only reason why we have this database is that we have to create those intermediate tables, and we'll be dropping them immediately after the query is finished. So we never persist anything in that database. If you want to create a federated extract, that's a different story. You use this database just to perform the federation, and later on you get the data and move it to a separate database that will be your federated extract. What is not supported or not supported yet? Some connectors, because they had a very unique interface, let's say Salesforce or SAP, published data sources are not supported, which means that if you access the data sources on the data server, you cannot put them on the data prep canvas and join them. You can do the opposite. You can take a federated model and publish it as a single data source. But you can imagine that if we allow, and we will allow the functionality to do both, we immediately get to chain of dependencies. That now you federate something that is published, we publish it again, then we federate again, and you need to somehow come up with a good interface of how to maintain extracts, how to refresh them, so it's not too complicated. I mentioned already that some of the functions are not supported. Some of them also have different semantics. Regular expression functions on SQL Server work very differently than on Oracle, and we have to be sensitive to that because it's confusing when you use multiple connections and you just drag one of the calculations on your canvas. If with a single data source, you can expect, well, this is what it is. So you will have situations where there was a dashboard that worked perfectly, and then you dragged a new connection, and suddenly you see a red bank somewhere on your calculation, simply because this calculation is not available anymore. That will not happen often, but at this point it will. Also, I mentioned that we have two types of joins. Some are federated, some are not. For the federated ones, we don't have primary foreign key constraints, so you cannot get join calling. For the others, it really depends on the metadata of remote data sources. What you can do, you can say, assume referential integrity. So you have this go fast button. It works exactly the same way as it used to. And sometimes it actually tells the truth, because if you are part of an organization that has a lot of restrictions around external catalogs with, let's say, customers, products, and they are enforced somehow, then yeah, that's true. You build your Vs probably against a fact table with multiple dimensions like that, and you can say, just assume that, that we match uniquely. If you, yes?
My last slide, does that mean that
What I said that, well, it did, but that's separate. We added a few rules to join calling, but no, for example, for this clump of tables against hyper, because we have primary foreign key constraints defined, we'll do some join calling within that part of the join. But without choosing the enforcement of integrity, you cannot really do any join calling across databases. So that didn't change. What I was trying to say is that if you choose it, then it works exactly as before. Then you don't distinguish between federated joins. You just assume that the referential integrity is defined everywhere. Yeah, so it did not get that much smarter. The data engine, in-memory database mostly, but not gonna crash if you have more memory than, if you need more memory than your query requires. Vectorized processes data in parallel, works on highly compressed data, and we use it pretty much everywhere, right? On Tableau Online, Tableau Public, on-premise deployments, short of the ones where you just use your backend database. And we also use it as a processing unit, and that's exactly what's happening here in our federated scenario. For live queries, we bring all the data just to post-process in the engine and then consume the result. But in the case of the extract scenario, we built a database. We built a database, persisted, and then users can connect like to a standalone database. Very soon, we will be replacing the data engine across the whole organization, across all the products with Hyper. And that will be much closer to a standalone database. It has capabilities that will allow us to change how we extract the data, how often we refresh the data, so there will be more functionality, and of course, performance. Also, you'll be able to interact with Hyper more than with the TDE. Today, you just have very simplified TDE APIs to, for example, create extracts from other tools. Two optimizations that I wanted to mention. Imagine that you are in the data prep pane and you just want to see a data preview. So you expect that it should be really fast. Just generated your model and you want to see if it returns any rows. Well, actually, that takes a lot of time if you do it the way we just showed by creating temporary tables, simply because the data movement is really expensive. And in the data preview, we show all the columns, right? Not just keys, not what is referenced. So let's look at the scenario when you bring sales and customers from Oracle, and you even have a data source filter on customers. Let's say that you just bring customers from the US. You have to send those 3 queries. You bring on the sales, and let's say that's billion of rows, and then customers, and then finally you run a query. Here I use SQL instead of TQL just for simplicity, and then you run a query against the temporary tables. And let's say that you're asking for top 1,000 matches. Well, then you can bail in the data engine, but you still waited to pretty much bring all the data on our side. So it's like creating an extract just to get a preview. What we changed, we allowed data engine queries to send SQL queries directly and to stream the data directly from remote data sources to the data engine query. So as we are processing the data engine query, we can consume as much results as we need. To do that, we allow the data engine to talk to protocol servers. Protocol servers are those processes that we are creating for every single physical connection. So let's say we open 10 connections to Oracle, we'll create 10 of them, just because they might crash and we don't want to bring down the whole server, Tableau server. So everything that speaks protocol server API can speak directly to the TDE now. In particular, the data server cannot. That's why we do not support this functionality for the data server yet. So now this whole scenario will be handled by the single query against the data engine. Again, I used SQL. So we are joining an embedded query against sales and embedded query against customers. And then as we are scanning the results, retrieving more and more sales, after we match 1,000 customers, we can just bail. So instead of bringing billions of data, maybe we just brought exactly 1,000, if we're lucky. And the last optimization is about union. I mentioned that we generate one big table for all the files that we want to union. And that's because all the queries that will be coming later need to be fast. But even the preparation of union is a challenge, because you are in the data prep pane and you want to just model your data. And you don't really want to wait much. You just want to define your joins and see the preview. And I mentioned that we create a shadow extract for text and Excel. So now imagine that you have 1,000 files that you want to union, and you would create 1,000 tables for every single one of them. And they are represented as files. Each column is represented as a file. You would have hundreds of thousands of files just to do that. For text, we are using something similar to the remote operator. We actually have our native parser inside of the data engine. So then you can union and directly process the data without materialization of those tables. And you will see that actually in the demo. We also balance the union to make sure that we don't have like a long chain of unions that will be also very, very expensive to execute. And this is how the query really looks like. We are just unioning directly streams of data.
Cool. I will quickly show you examples of these concepts. So Pavel talked about pushing down of filters. I mentioned it also in the beginning. So the first thing I'm going to show you here is using this viz, which is fairly simple. What I'm going to show you here is I have filters, in this case, on 3 different fields. I've constructed them, of course, in a way to kind of make these points. So let me just quickly show you. My full Kavak code field is defined as a very simple concatenation of 2 fields, basically putting the code together with the description. The point here is that Kavak code comes from one data source, whereas description comes from another one. And the other calculation I have here is similar, just in this case, both of these fields come from the same data source. And so let's see what that looks like if I refresh this sheet. I'm just going to refresh it here. And then we're going to take a look at what's going to happen in the log viewer again. Let it finish. Are we done? Let me check it finished. It did. So I will just move it over. Sometimes the log viewer didn't pick up everything. There we go. Perfect. Okay. So what's happening here is I'll start at the bottom here. Remember last time I showed you what the federated query happens at the end after we create all the temporary tables? And what we're seeing here is that step, but there's a few more, little more information in the view this time. But what you'll see here, if I scroll down, you'll see that, I'll have to do it without zooming, like this. You'll see here that one calculation, that concatenated report type description and visibility variability code, long names, apologize for that, is not pushed down to the backend database because it's referencing columns from different connections. So that happens after we retrieve the data in the TDE, in the data engine. Whereas the other filter that I showed you, plus a third one that I had, is against the same data source. So in this case, you will see here that I have a where clause, and the calculation happens here, the filter happens here, both the one that says I only want descriptions that are no, but also I had a simple filter on another field here, which was just select only these 5 different categories. So just a quick way to take a look at what's going on here. And again, if you're not certain, you're trying to debug a scenario at home, you can go and look for it here and see where things actually end up happening. The last thing I'll show, because I know you have other things to go to as well, is the remote query part that Pavel talked about. So if I go here to the data pane, the data source pane, and I retrieve data, we will stream data in as Pavel outlined. And I will just show you what that looks like here again in the log behind the scenes. So down here, you will see, I'll make it a little bit bigger here. You will see as you scroll down here that there are several of these remote query nodes here that creates a temp table, and it populates the temp table with the SQL statement that you see below right here, which goes against whatever connection you're doing it with. So each one of these will be retrieved with a SQL statement from the various data sources I had for this demo, and the data will be populated into the temporary table as shown here. Looks like I'm going to switch back because we're very close, if not at the end.
Just pretty much the last thing for you to know what we are planning to do with data federation in Tableau. 2 things, add more functionality and performance. We just shipped write and full outer joins in 10.1. We'll be adding more connectors. I mentioned integrating of published data sources. That's very important, but also integrating Salesforce connections with incremental refresh. That's coming. For performance, we want to push more operations, like in particular aggregations. We'll be pre-aggregating the data. Most of federated engines actually do not do that. We are almost done with this. Also, we don't want to send queries against remote data sources serially anymore. We want to send them in parallel. That will be really the most important improvement. Another interesting one, it really depends on the scenario, but it might be the case that all your data is your Teradata appliance, and then you just want to take this Excel spreadsheet with the hierarchy of your employees and your departments, and you want to federate it. It will be really nice to keep the data in the Teradata appliance. So we want to allow users to explicitly say, hey, don't move this data. This will be my federation engine. That's harder because we need to actually test those databases if they have enough capabilities, if we can maintain the right semantics. We want to do the streaming that I mentioned for Union for Excel. We don't have it today. We also want to enable you to have unions of tables across databases. So you have your operational data source with fresher data, and then you have your data warehouse with the same data, historic data. Why not just combine it as a single union? The same production versus test system. Yeah, so this is coming. Yeah, thank you very much, and we can take a few questions.
Thanks.